Hello students, this is Sudhir Kumar Jha and today we will discuss about arithmetic progression. So what is an arithmetic progression? So we can see that an AP is a sequence in which the difference between any two consecutive term is a fixed number. So according to the definition, we will see an example. Example number 1, 1, 2, 3, 4, 5, 6, 7. We have 7 terms and the difference between any two consecutive term is a fixed constant. That is, if we see the difference between first term and second term, then we will get here difference is 1. Now we want to see the difference between fourth and fifth term, then the difference between fourth and fifth term is also 1. Here difference 1. So difference between any two consecutive term is a fixed number, that is 1. So we can say that this sequence is an AP. Now we want to see the another example. 2, 1, 3, 4, 5, 8, 9, 10. Now we have 7 terms here. So the difference between first term and second term is 2. The difference between second and third term is 1. The difference between fourth and fifth term is 3. The difference between sixth and seventh term is 1. So here the difference between any two consecutive terms is not a fixed number. So we can say that this is not an AP. Now we want to derive the formula for nth term of the AP. So let A be the first term. That is, we represent term by T. So first term is T1. T1 equals to A. And here we missed one thing, that this difference is called common difference. And we represent it by D. So now let A be the first term and D be the common difference. Now according to the definition, an AP is a sequence in which the difference between any two consecutive terms is a fixed number. So we can write the difference between any two consecutive terms. So we can write T2 minus T1 equals to T3 minus T2 equals to T4 minus T3 equals to, and so on. Nth term, that is Tn minus n minus 1th term, that is Tn minus 1 is equals to d, because this is the common difference. Okay, from here we can write T2 equals to T1 plus d. From here, if we equate T3 minus T2 equals to d, then we can write T3 equals to T2 plus d. Similarly, we can write T4 equals to T3 plus d, and so on. The last term will be Tn equals to Tn minus 1 plus d. Now, we know that T1 equals to A, so we will write A at the place of T1. So, it will be A plus d. T2 equals to A plus d. Now, T3 equals to T2 plus d. So, we will write A plus d at the place of T2. A plus d and plus d for this d. T4 equals to, that is, here we will get A plus 2d, T4 equals to T3 plus d. Now, T3 equals to A plus 2d, so it will be A plus 2d plus d, which is equals to A plus 3d. So, the Tn will be okay. Now, we can see here that we can write it A plus 2 minus 1 into d, that is 42. 42, here we can write 2 minus 1. 43, we can write A plus 3 minus 1 into d. Similarly, 44, we can write A plus 4 minus 1 into d, and so on. Here we have T4. So, now we can see that 42 we have 2 minus 1, 43 we have 3 minus 1, 44 we have 4 minus 1. Similarly, for Tn, we can write A plus n minus 1 into d, and this is the formula for finding the nth term of the AP. Thank you so much.